Sometimes we care about the convergence of an integral, but not actually its value. We just want to know if the area underneath a function is going to be finite or not. So we can do this by directly comparing the unknown integral with an integral that we know to converge or to diverge. So let's think about the integral between 1 and infinity of the function e to the minus x squared. So that is, in blue, e to the minus x squared is this curve here. So I want to integrate that from 1 to infinity. I want to figure out if that has a finite amount of area underneath it. So this is a question. So if I can bound this function above by a function that I know has a convergent integral, I can then claim that this integral has to be less than that one. And I claim that e to the minus x squared is always going to be less than or equal to e to the minus x. Now, maybe not always, but at least on this interval, on the interval 1 to infinity. In fact, we see that here. The blue function is bounded above by this red function, which means that if there's a red finite amount of area, then there has to be a blue finite amount of area, because the area of the blue has to be less than the area of the red. So because the unknown function is bounded above or dominated by e to the minus x, if I can show e to the minus x has a finite amount of area underneath it, then e to the minus x squared must also have a finite amount of area underneath it. So from 1 to infinity, e to the minus x dx. If we perform an integral, we have minus e to the minus x between 1 and infinity. So e to the minus infinity approaches the value of 0. And we have minus a minus e to the minus 1. So this becomes e to the minus 1, or about 0.368. So the red area, 0.368, has to be more than the area of the blue area. So this integral has to converge because it can't be any more than 0.368. So in fact, we have an upper bound for this integral. It can't be more than 0.368. This function was bounded above, it was dominated by a known converging integral. So we get to claim that it converges. One slightly different question, does the integral from 0 to infinity of this function converge? So let's see here. If I know that the area between 1 and infinity underneath e to the minus x squared converges, so that's a finite amount of area right there. Well, I also know that the integral between 0 and 1 also has to converge because it's a bounded function, right? It doesn't ever approach, or it doesn't ever get bigger than 1, and it's on a bounded domain from 0 to 1. So whatever this area is, it has to be finite. And if I know that the rest of the integral from 1 to infinity is also finite, then the integral from 0 to infinity, also finite, it converges. So main idea behind direct comparison or dominated convergence. If you have some unknown function that decays and you're wondering if it has a finite amount of area underneath it, if you can bound it above by some function, which also has a finite amount of area underneath it, then the area you want must be smaller than that, so it must also converge.